When feeding a multi-load lighting control module with a 12 American wire gauge or OG 20 amp circuit, you can use number 14 wire for the switch legs. The National Electrical Code, or NEC, specifies the minimum wire size for switch legs in a lighting circuit is number 14 AWG. The reasoning behind this is that switch legs typically carry very little current. Therefore, using a larger wire size is generally not necessary in this type of application. In the situation of a 12 AWG 20 amp circuit providing power to the multi-load lighting control module, the size is suitable for supplying the necessary power. The smaller number 14 AWG wire that is used for the switch legs will be adequate to handle the low current that those switch legs will carry. Consequently, it is an acceptable practice to use number 14 wire for the switch legs in this specific configuration. To further elaborate, the NEC provides guidelines on the appropriate wire gauge for different applications based on factors like ampacity, which is the current carrying capacity of the wire, and the type of insulation. For general lighting circuits, number 14 AWG wire is commonly permitted for 15 amp circuits, while number 12 AWG wire is typically used for 20 amp circuits. However, switch legs are a special case because they only carry current when the switch is closed, and the current demand is usually minimal. It is important to consult the specific requirements outlined in the NEC and any applicable local codes to ensure compliance with the electrical regulations. These codes are designed to ensure the safety and proper functioning of electrical systems. Factors such as the ambient temperature, the type of wiring method used, and the presence of other conductors in the same conduit or cable can also affect the appropriate wire size. These factors are considered to prevent overheating and potential fire hazards. It is also important to consider voltage drop when selecting the wire size, especially for longer circuit runs. Voltage drop refers to the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause lights to dim or equipment to malfunction. The NEC provides guidelines for calculating voltage drop and recommends using larger wire sizes to minimize it. In summary, using number 14 wire for switch legs in a lighting control module fed by a 12 AWG 20 amp circuit is generally acceptable according to the NEC. This is because switch legs carry very little current, and the larger wire size is not needed. However, it is always crucial to consult the latest edition of the NEC and local codes to ensure compliance with all applicable regulations. It is also advisable to consult with a qualified electrician to ensure the electrical system is safe and properly installed. Always prioritize safety when working with electrical systems, and follow all applicable codes and regulations. Furthermore, it's essential to understand the specific requirements of the lighting control module being used. The manufacturer's instructions and specifications should be carefully reviewed to ensure compatibility with the chosen wire gauge and circuit configuration. The lighting control module may have specific recommendations or limitations regarding wire size that must be adhered to. For example, some modules may require a specific minimum wire gauge for the switch legs to ensure proper operation or to comply with safety standards. In addition to wire gauge, the type of wire insulation should also be considered. The NEC specifies different insulation types for various applications based on factors such as temperature rating, moisture resistance, and chemical resistance. The appropriate insulation type should be selected based on the environmental conditions and the specific requirements of the installation. For example, conductors installed in damp or wet locations may require insulation with a high moisture resistance rating. Additionally, the wiring methods used should comply with the NEC and local codes. Common wiring methods include non-metallic sheath cable, also known as Romex, electrical metallic tubing, or IMT, and rigid metal conduit. Each wiring method has its own advantages and disadvantages, and the appropriate method should be selected based on the specific application and the environmental conditions. For example, EMT is often used in commercial and industrial settings due to its durability and resistance to physical damage, while non-metallic sheath cable is commonly used in residential wiring. It is also essential to properly terminate the conductors at the switch, the lighting control module, and the circuit breaker. Loose or improperly terminated connections can cause overheating, arcing, and potential fire hazards. All connections should be made using approved methods and devices, such as wire connectors, terminal screws, or crimp connectors. The connections should be tightened to the manufacturer's recommended torque specifications to ensure a secure and reliable connection. Furthermore, it is crucial to properly identify and label all conductors. The NEC requires that conductors be identified by color coding or other means to indicate their function. For example, the grounded conductor, also known as the neutral wire, is typically identified by a white or gray color, while the equipment grounding conductor is typically identified by a green or bare color. Proper identification of conductors helps to prevent accidental contact with live wires and ensures the safety of personnel working on the electrical system. In addition to the technical aspects, it is important to consider the aesthetic appearance of the wiring installation. While functionality and safety are the primary concerns, a neat and organized wiring installation can also enhance the overall appearance of the space. Wires should be neatly bundled and secured to surfaces using appropriate fasteners, and excess wires should be trimmed to avoid clutter. A professional wiring installation can also make it easier to troubleshoot and maintain the electrical system in the future. In summary, when using number 14 wire for switch legs in a lighting control module fed by a 12 AWG 20 amp circuit, it is crucial to consider all applicable codes, regulations, and manufacturer's specifications. The wire gauge, installation type, wiring method, termination techniques, and conductor identification should all be carefully selected and implemented to ensure a safe and reliable electrical system. Consulting with a qualified electrician is always recommended to ensure compliance with all applicable requirements and to avoid potential hazards. Remember, electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from harm. Always disconnect power to the circuit before working on any electrical components, and use appropriate personal protective equipment, such as safety glasses and insulated gloves. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Moreover, consider the impact of energy efficiency when designing and installing lighting systems. Energy-efficient lighting technologies, such as LED lighting, can significantly reduce energy consumption and lower electricity bills. LED lights consume significantly less energy than traditional incandescent or fluorescent lights, and they also have a longer lifespan. When selecting lighting fixtures and control modules, look for products that are ENERGY STAR certified, which indicates that they meet certain energy efficiency standards. In addition to using energy-efficient lighting, consider implementing lighting control strategies to further reduce energy consumption. Lighting control strategies can include occupancy sensors, which automatically turn lights off when a space is unoccupied, and daylight harvesting, which adjusts the level of artificial lighting based on the amount of natural light available. These strategies can help to reduce energy waste and save money on electricity bills. Furthermore, consider the environmental impact of lighting systems. Traditional lighting technologies, such as incandescent and fluorescent lights, contain hazardous materials such as mercury, which can pose a risk to the environment if not disposed of properly. LED lights do not contain mercury and are considered to be more environmentally friendly. When disposing of old lighting fixtures, it is important to follow local regulations and guidelines for proper disposal. Many communities offer recycling programs for fluorescent lights and other hazardous materials. In addition to energy efficiency and environmental impact, consider the quality of light produced by lighting systems. The quality of light can affect mood, productivity, and overall well-being. Factors such as color temperature, color rendering index, or cry, and glare should be considered when selecting lighting fixtures. Color temperature refers to the warmth or coolness of the light, measured in Kelvin or K. Warmer light sources with lower Kelvin temperatures tend to create a more relaxing and inviting atmosphere, while cooler light sources with higher Kelvin temperatures tend to create a more energizing and focused atmosphere. CRI refers to the ability of a light source to accurately render colors. A higher CRI indicates that the light source is better at rendering colors accurately. Glare can cause discomfort and eye strain. It can be minimized by using fixtures with diffusers or reflectors that spread the light evenly and by avoiding direct light sources in the field of vision. In summary, when designing and installing lighting systems, it is important to consider a variety of factors, including safety, energy efficiency, environmental impact, and light quality. Consulting with a qualified lighting designer or electrical engineer can help to ensure that the lighting system meets all applicable requirements and provides optimal performance. By considering these factors, it is possible to create lighting systems that are safe, efficient, environmentally friendly, and aesthetically pleasing. Finally, always ensure that the circuit breaker protecting the 12 AWG 20A circuit is properly sized and functioning correctly. The circuit breaker is designed to protect the wiring from overcurrents and short circuits. If the circuit breaker trips frequently, it may indicate a problem with the wiring or the lighting control module. In this case, it is important to investigate the cause of the problem and correct it before restoring power to the circuit. Never replace a circuit breaker with a higher rated breaker, as this can overload the wiring and create a fire hazard. The circuit breaker should be properly labeled to indicate the circuits it protects. This can help to prevent accidental disconnection of power to critical equipment or lighting. Regular inspection and maintenance of the electrical system can help to identify potential problems before they become serious hazards. This can include checking for loose connections, damaged wiring, and corroded components. Any problems should be corrected promptly by a qualified electrician. In addition to the NEC, other standards and guidelines may apply to lighting systems, such as those developed by the Illuminating Engineering Society, or WISE. The IES provides recommendations for lighting levels and lighting design practices for various applications. These recommendations can help to ensure that the lighting system provides adequate illumination for the task being performed and that it meets the needs of the occupants. Furthermore, consider the impact of lighting on the overall building design. Lighting can be used to create visual interest, highlight architectural features, and enhance the functionality of the space. Careful consideration should be given to the placement of lighting fixtures and the selection of lighting technologies to achieve the desired effect. Lighting can also be used to create different moods and atmospheres. For example, dimmable lighting can be used to create a more intimate and relaxing atmosphere, while brighter lighting can be used to create a more energizing and focused atmosphere. The lighting control system should be designed to allow for flexibility and customization of the lighting to meet the changing needs of the occupants. In summary, lighting is an important aspect of building design and should be carefully considered to ensure that it meets the needs of the occupants and contributes to the overall functionality and aesthetic appeal of the space. By considering safety, energy efficiency, environmental impact, light quality, and building design, it is possible to create lighting systems that are safe, efficient, environmentally friendly, aesthetically pleasing, and functional.